In the second part of section 4.5, we're going to explore a little more detail about what's going on in the creation of this voltage in the DC generator. We want to look at something in particular called a neutral position and the effect that that has on this operation of the DC generator. So again, here's this 12 coil DC generator that we've been looking at and exploring a little more detail on. One thing I want to point out, and I didn't mention this in the first video in this section, but here's the physical construction of the generator. And one thing I want to just kind of point out to you, this thing is getting a little more complex, actually a lot more complex than our original DC generator that we looked at. But, let's just look at one coil, and remember you can do this 12 times on this particular generator. And what we're looking at is here's a coil A, and here is also coil A, right? And so if this was one side of coil A where I just placed that little green dot, and it was on the top, then on the other corresponding side to this, it would be on the bottom. That's that lap wound idea. Now, what I want to point out, and I hadn't said before, is look that each coil has to be connected to a commutator segment, because that's how we pick up the voltage, right? So this one side of coil A is connected here, and the other side of coil A here is connected at that point. So we're seeing this connection between the coil and the commutator segment, and that happens 12 particular times on this generator. All right, so when we look at 411B, which is what we're looking at here, here's the schematic diagram of that physical representation, and we're looking right now at coil A. All right, so when you look at this, I want you to think about something here. Here's a coil, and it's connected to this commutator segment here from one side and here on the other side. The brush is conductive, and so it's going to conduct from this side of the coil to the other side. Now, if that coil voltage is at 0 volts, then Ohm's law says 0 volts divided by 0 resistance, right? Because we're assuming there's no resistance here in a perfect world. So we're 0 ohms, right? Of course, division by 0 is not allowed, but anyway, we would see voltage divided by resistance gives us a current. But in this case, since there's 0 volts, there is 0 current flow. That's very important in the operation of this generator, because that's the condition we want when this thing is going through the voltage generation process. We want it such that when that those two segments that are connected there are shorted out by the brush, then we want there to be 0 volts there. Because look, check this out. Let's say that, for instance, we were here, right? And actually, I think we have a picture of a situation where there's a shifting between what we call the neutral point. This is neutral position, and this is exactly what we want. But if for some reason there was a shift, and instead of shorting out a coil at 0 volts, and this can happen internally through some things that occur from like magnetic flux saturation and so forth and so on, this neutral point gets shifted, okay? And look what happens. Now I'm shorting out 2 commutator segments. that have a voltage of 7 volts across them. Okay, now let's say that the resistance with the brush and the commutator segments, let's say it's really very small. Let's say it's, you know, just almost an amount that's unmeasurable. And let's say it's 0.1 ohms. Okay, 0.1 ohms. Even in that situation, 0.1 divided into 7 volts would give us 70 amps across there. Okay, well, you think, okay, so what's the big deal? Well, what happens when that occurs, when you short circuit the coil sides and they have a voltage across them, you get this arcing and sparking and all this sort of thing, which is a really troublesome, bad thing for that to happen inside of a generator, because it'll burn up the brushes, it'll burn up the connection points, you know, carbon buildup and all that will occur. And so, you know, we don't want that to happen. He calls this poor commutation, and that's a direct result of, you know, the brush shorting out a coil that doesn't have 0 volts across it. All right, so that's something that we try to avoid, and we'll look at that a little bit more, you know, and how we avoid that in future segments in this chapter. But this is the condition that we strive for: 0 volt coils being in that position so that no current flows during the operation of this thing.